Good. We start with symmetric cryptography. Like I said, it's just when we use a single key, a single secret key for both the encryption process and the decryption process. So what it means is that we don't need to even go further. Just from what you can see on the screen, it easily explains what we are doing. Moving further, there are different cryptographic processes which you can always go through them. Let me see, whenever it is you want to. Now, look at this illustration given to you here. Look at this illustration given to you here. Abdullahi enters the 21st century. Abdullahi wants to register an account on her favorite social media. Here is what she does. Can you spot any security flaws? This is Abdullahi. This is the favorite social media. He enters username / password. Username / password was sent to the social media sites across the internet. When Abdullahi wants to log in, he sends his username / his password. All his status messages are then encrypted with the password. Now, they're asking you if you can spot any security flaws. You have the answer. You can put it in the Ask Your Questions platform. So let's proceed. Asymmetric cryptography, like I said, it has different keys for the encryption and decryption. For the encryption, you have the public key. For the decryption, you have the private key. This private key is only known by this receiver. Public key is known by both the sender and the receiver. So let's proceed. The reason why I'm explaining this is for the sake of those that want to write exam. Let me see one exam in cybersecurity. You need to actually understand this concept very well. For asymmetric cryptography, this is let's call this person Alice. In different tests, they like using Alice as example. Let me see they like using Alice as example. So let's say this is Alice, this is Bob. They want to send a message to each other. Now, Alice encrypts a message, but she's going to use Bob's public key. Upon going, definitely Bob is not going to read the message in encrypted format. He's going to decrypt it. So to decrypt the message, Bob is going to use his private key to do that. So it's just good you know you know that for asymmetric, the encryption process is encryption and decryption process. We're actually using different distance. We're actually using different keys. You can go through this illustration here for sake of simplicity. You're going to understand it better. So please go through all these pictures attached here. You can actually go through them. The moment you see them, you're going to understand it completely. So we have the advantages and disadvantages of asymmetric keys. So I've given actually different insights you can use to understand what I explained earlier on. Let's quickly move to various cryptographic techniques that we have. Let's look at various cryptographic techniques that we have. I'll be sharing you, I'll be going through another slide that I prepared. We have Caesar cipher, substitution cipher, engineer cipher, like I said before, hashing functions, block functions, stream ciphers, RSA. I'm going to explain those ones that we actually need. I'm not going to explain everything. Caesar cipher, I've already talked about it, popularly known as 13. What happens? It's actually a shift to the 13th alphabet. It's a shift to the 13th alphabet. Same goes with substitution cipher. Caesar cipher and substitution cipher, they are the same thing. Just as substitution cipher is not 13. Substitution cipher can be anything you choose. Don't let the person that is receiving it know. Let's say I want to communicate with Christiana again. I can actually tell her that, hello, the cipher I'm using is just like the fourth shift. It's the fourth shift. Always know that one. It's the fourth shift. Always know that one. Anytime I send a message to her, all she needs to do to decrypt the information is take it to the first shift. Then she's good. Now, let's talk about one very important thing, which is hashing. very, very important, which is what? Hashing. Now you can see what I wrote on the screen. Hashing function. Hashing functions are one-way functions which theoretically provide a unique output for every input. MD5, SHA-1, and other hashes, which were considered secure, are now found to have collisions or two different pieces of data which produce same unique output. Now let me explain to you in a way that is going to make sense. I would actually like somebody to be with me on this, so I should make it a bit conversational. Okay, Michael Akinwole. Okay, anybody who is like okay, Michael Akinwole. Michael, can you speak? Let me hear from you.
Yeah, I can speak. I'm with you, sir. Good afternoon.
Okay. Thank you very much. Now, Michael, this is what we are going to do. We are going to have like a kind of conversation, but then I'll be explaining it at the same time. So
okay,
now,
sir.
let's say I want to send a message to you, Michael.
Okay, sir.
You're a guy. I would have used "I love you," but I don't like that. I don't like that vibes that's passing out. Let's find it. Okay, let's. I want to send you a text. Now,
Okay.
that text. Remember what me and Samuel did when we were shifting it. The algorithm we used. Let's say we used third shift. Was the was the algorithm we used, right? Now, you wanted to send BEG to me. Let's say I want to send BEG to you. Eventually, I ended up sending EFJ, right?
Yes, sir.
Let me go through that stuff and see what we got. So give me 1 minute. Me and Samuel, we got EHJ, right?
Yes.
Yeah. Okay, good. EHJ. Now, imagine I send EHJ to you. What are you going to do to that EHJ? I'm sure it doesn't make sense. EHJ does not make sense. What are you going to do?
I will have to ask you what algorithm you use to encrypt it.
Yes, good. Now you already know that the algorithm I use to encrypt it is shift 3. Let's use the word shift 3. Good.
Okay. So I have to.
What will you do to get the meaning of what I've said?
I will decode it.
You decrypt it, right?
Yes. I will decrypt it, which is bad.
Do you agree with me that with two? Yes, thank you. Do you agree with me that two things have actually been done? Me, I want to send you a message. The plain text BEG, which is beg. What did I do? I encrypted it. I sent it. Yeah. I encrypted it as the first action. Now, you've gotten the information BEG. You want to make meaning. No, you got the information EHG. You want to make meaning out of it. You have to do something. What did you do?
I decrypted
it. Right?
Yeah. Yes, sir.
Yes, thank you very much. Now, hashing is when, instead of that two-way, the way I did, then Michael did, hashing is when it is just one way. Nobody is encrypting, nobody is decrypting. I don't know if that makes any sense. Michael, still using you as example. I send you a message. Yeah, I send you a message. But now, instead of me to send you a message, now for you to now ask me, what's the algorithm you use? But this time around, they're not asking anything. It's just like there is a particular output using one algorithm or using one technique. There's a particular output for that stuff. I know. Does that
Okay.
make any sense to you, Michael?
Which means after you have encrypted it from your hand, when it gets to my hand, it will be decrypted
Yes.
automatically.
No. That's good. I like the way we're actually conversing. It's not going to be decrypted. Okay.
So how will I
I'll
get
explain
what
it in
it
such a
is
way that
without being?
okay, okay. Let me put the explanation this way. Okay, thank you, Michael. Let me put the explanation this way. Yeah. I'm trying to explain hashing. The way cryptography, the way encoding and encoding, encryption, decryption, the way they are all popular, that's the way this thing is also very popular. Hashing is also very popular because most passwords are actually hashed. You see, hashing is like when we want to transform data into like a fixed size of string. Definitely normally appears as, let me say, random um, sequence of letters or numbers. Now this, when we transform it, we actually call it hash. Now this hash is actually unique to the original data, meaning that even the smallest change in the input will result in what? In a completely different hash. Okay, let me put it in this way again. Just imagine now that you have like a big book and you want to create a unique code for every page. Instead of writing a summary of each page, you decide to use a special method to generate like a short fixed length code that will represent every content of the page. This code is like a fingerprint for the page. So no two pages can have like the same code unless they are exactly the same. If that still doesn't make sense, let's look for another way to explain hashing. Because you actually need to understand what I mean by hashing. Because you always see it, we always use it. Um, let's say, still going by that previous example I used, I still want to use that example again. You have a book, page one, it has content, stuff's written in it. Automatically, I'm not explaining, automatically, you already know that I can tell you that page one, the representation of page one is 245. That's the representation of page one. So let's say you now go to America and you enter a library, you now input 245. They are going to refer you back to that particular page. They will refer you back to that particular stuff in that my book. That is one way of explaining this stuff. Let's move to different types of it. Let's see if we can from different types. Let's see if we can understand it further. Let's go to the stuff that I have. Now we have string hashing. A string hash is a number or string generated using an algorithm. So we have different types. We have SHA-1, SHA-2, MD5. We also have file hashing, which we can use for what? This thing. We can use for different files. Now let us ask ourselves, what is the meaning of this thing I wrote here? SHA-1, SHA-2, MD5, and the likes of them. Sorry, 1 minute. Sorry, please, 1 minute. Okay, let's continue. Okay, now looking at the example that I gave there, what can you discover? This word password, it has like what? And it's being stored as a hash. What is the hash? 31954. This hash is for what? MD5. This hash is for what? MD5. Now it has what? If you count it, you will discover that it has a specific length output. It has a specific, like the fixed length output. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. MD5 what is 32. Let's explain, let me explain to you the difference between this hashing that we are talking about and normal encryption, decryption that we know. Now, definitely, we know that both of them are techniques that we use in cryptography, right? They all have their different purposes, right? Good. Now, hashing converts data into like a fixed size string. We just established that for MD5 is what? Is 32. The character must be 32. That's the output must always be 32. So the moment you see something like this, you can see just 32 fixed length. You know that is what is MD5. Alternatively, how does encryption look like? Encryption converts data into what? Different formats. All we need is what? Is a key. So that only somebody that is with the appropriate key can actually decrypt that stuff that we are talking about. So like me and I've forgotten his name. Like me and him established, encryption is a two-way function. It allows data to be both encrypted and decrypted. Mind you, hashing doesn't work that way. Hashing is a one-way function, meaning it cannot be reversed to what obtain the original data. It's just as it is. Take, for example, now you have your password as, let's say your password is Ikemu, IKEMU. You want to save it on Facebook server. They will use a particular hash for it. They have like a particular hash for that password. So the moment it's going to be saved in their server, the thing is not going to be saved as Ikemu in their server. It's going to be saved with that hash. So it's not like a kind of hash that when I give you the hash now, you're not going to say, sir, which algorithm did you use for it? You now get the algorithm and you're not going to decrypt it. There's nothing like that. Another very key difference between that encryption and hashing is that reversibility. Like we said, hashing is not reversible. Once the data is hashed, it cannot be converted back to its original form. That is why that's what makes hashing useful for verifying data integrity. You know what I mean by data integrity? I already explained it before that its substance has not been changed. So, for example, passwords. But encryption, just like he said, we have encryption, we have decryption. Something can be encrypted. As it is encrypted, the person that has gotten the information can what? Decrypt it to see what is there. Now, for the output, how does it look like? For hashing, it has a fixed length, just one particular length. Look at the example I gave on the board. Jesus. I said on the board, sorry, on the screen rather. Password. We counted this thing is 32, right? What does that tell you? MD5 is for what? 32. It's just 32. The moment you see something like this, a 32 bits, I mean 32 bits is like 32 characters. Where it's MD5 automatically. That's MD5 hashing. That is that MD5 hashing that they use. So Anas, I think you're the only one. The next another one that we have is what SHA-256. SHA-256. SHA-256 is this is 256 bits. Like the characters, the output are going to have for it. So let me show you different hashing techniques and how you can easily recognize them. Okay, you can see, let me look at what we have there on the screen. Let's start from this cryptography here. The overview. I won't explain anything that is not important. Substitution cipher. We already know what substitution cipher is, right? So no need to. We we already know what substitution cipher is. So mere looking at it is what I explained earlier on. Okay, moving further, we already explained this one too. Caesar cipher, which is the very popular one, ROT 13. Yes, it's not changing. I'm showing you a page. If you can see the page, then it means you are fine, you are cool. I'm showing you just a web page. It's actually changing. Now I'm on Caesar cipher, which I already explained earlier on. Moving down to hashing functions, which is the reason why I brought you here. So all these things that they're actually showing here, they are things I've explained before. I want to bring out something to your notice. This is what I want to bring to your notice. You can see this MD5 is quite popular, it's quite popular. This MD5, the hashed value is always 32 character long. So if you have a file, in your in your system, you want to get like the hash value. You see that file? This is an example. They wrote MD5 sample file.txt. It's going to give you, this is the hash value. Now, the moment you change something in it, I'll load my Kali. We are going to show this demonstration. The moment you change something in it, like you change a particular content of that file, just know for certain that that MD5 value will change. It's going to be another thing entirely. I don't know if what I'm saying is making any meaning. Okay, I'm going to load up my Kali. I would like, let me see, typify what I am doing. Now, hash collision. Hash collision is when it's just like an error whereby two different pieces of data, they have the same hash value. It's not supposed to be that way anyways. It's not supposed to be that way. So while we wait for my Kali to load, it's going to, in a short while, it's going to load. While I wait for it to load, I'll go to the question and answer segment and just quickly pick a couple of questions to answer. Okay. Somebody is saying, okay, it's clear. So somebody is saying, where are ashes stored? Nice question. Now, the thing is that ashes can actually be stored in various places. Could be stored in, like now, let's use typical example, password ashes. Where are they stored? Stored in databases. That's different kind of databases. Also, you can use digital certificates or even signatures to store. Then, sorry, 1 minute. So, like I said now, they're actually stored in various places. Yeah. So depending on depending on their purpose or their context or whatever it is. Yeah. Next, another one. Somebody asks, what is the full meaning of MD and SHA? Okay. Now note that it's only maybe when you're doing like a theoretical stuff, let me say exam or something, that you're actually meant to know this. MD, I think it means message digest. Yes, MD should mean message digest. While SHA means secure hash algorithm. SHA. So MD message digest, SHA, secure hash algorithm. So I think that should be all talking about questions for now. We're not going to wait locally to keep loading, but just understand what I explained here, please. Very, very important. You can save a file. You see this sample file .txt. If you get the MD5 hash value for it, the MD5 hash value for it, the moment you change a content in this sample file, this value is going to change. So take for example now you have a very important document. You have a very important document that you want to save. It's on your PC. You now have the MD5 value saved somewhere. The moment you give that PC to somebody, now the person now access this file. The person now deletes something inside the file. If the person is returning your PC back to you, you can actually check. All you just need to do is run MD5 value of that particular file. If it gives you the same value, fine, it has not been tampered with. The integrity is still there. If it gives you a different value, that has been tampered with. So you need to now know what the person did while you were away. So let's go back to our presentation slide. So we are going back to the presentation slide. Okay, we've gone past all this. So here they were talking about hash functions, which I've already explained to us what they mean. Now, secure hash. Then we talked about hash collisions. Now moving further, talked about network encryption. Now they talked about link encryption here. Let's quickly talk about this. I know time is already against us, but then let's just talk about this. Encryption of the physical link between the two hosts. That's link layer. The link layer was now how is it useful when the transmission line is the point of greatest vulnerability? All application communications are encrypted automatically. So we can actually go through all these various stuffs ourselves to understand the different kind of encryption process or the different kind of cryptographic process or processes that happen when we communicate using our PC or using different devices. Like I mentioned before, these are our HTTPS. So how does it secure this thing? HTTP syntax plus SSL, which is this secure socket layer or near TLS. Then we have a certificate to verify the identity of the server and establish encrypted communication and channel between web browser and web server. Now let's talk about onion routing. Very interesting concept. I know time is against us, but this one is actually very, very interesting. I'm sure majority of you have heard of dark web. I don't know if we've heard of dark web. Now, in dark, there are, you see, the web, the entirety of the web is actually divided into three. Before that, sorry, please. Let's stop the recording here.